Precast concrete. What is precast? Precast concrete is a construction product produced by casting concrete in a reusable mold or form, which is then cured in a controlled environment, transported to the construction site, and lifted and set into place. Differences between precast and cast in situ concrete. Precast buildings are designed, manufactured, and tested under supervision of experienced management. The entire concrete blocks are cured uniformly for the required amount of time. Production is not hampered with weather delays. Aesthetically pleasing appearance. Environment friendly. Stationary equipment efficiency designed for repetitive production. Cost of formwork per unit to be lower than for site cast production. Greater flexibility. Design and manufacturing at the same location. Construction is faster. In case of conventional buildings, concrete cast at site where contractors do not take care of mixed designing proportions. Curing is not done uniformly at sites. Production is severely hampered. Special aesthetic design required. Non-environment friendly. Special design and features developed for each project at higher costs. Not flexible. Construction is comparatively slower. Precast elements. A precast building is constructed by assembling and connecting various prefabricated elements required in the building structure. These elements are precast slabs, precast beams, precast columns, precast walls, and precast foundation. Precast slab. Precast slabs are cast in a factory environment and include the following pre-stressed concrete options. Hollow core units. A hollow core slab offers the ideal structural section by reducing deadweight while providing the maximum structural efficiency within the slab depth. Precast floors are available with a variety of factory formed notches, slots, and reinforcement arrangements which offer various design approaches. Precast beams. Beams and beam shells are both used for suspended flooring. Beams are typically used as ledges for other forms of precast flooring to sit on, but can also be used as a flooring option in their own weight. They are generally manufactured to suit each particular situation, and profiles can include T-beams, L-beams, rectangular beams, U-beams, and beam shells. Beams can be either reinforced or pre-stressed. T-beams, either single or double, cover the span range beyond slab-type members such as hollow core planks. T-beams are a very efficient structural shape. The units are generally cast with straight strands or deflected strands depending on design considerations. The T-beams are the basis for the design of economical fire-rated structures where construction time, long spans, or heavy loadings are important cost influences. L-beam. L-beams have an L-shaped profile which provides a ledge for a precast flooring system to sit on. These beams are generally used to span clear sections and are reinforced or pre-stressed. Precast columns. Precast concrete columns are modular in design in order to be made into different heights. Widths are 12 inches, 18 inches and 24 inches. Columns are not structural, but can be used as such only after a structural engineer has adapted them to a building. Precast column can be produced as either single, first-story corbel column or multi-story corbel column. Precast walls. A precast wall system can be comprised of flat or curved panels, window or mullion panels, ribbed panels, and double T. Precast footings. Precast footings are a recent innovation. No holes need to be dug for footings as the precast blocks are set on grate and the post, column or beams fit in pockets cast in the concrete block. Precast concrete foundations are pre-engineered systems manufactured in a controlled environment. Type of precast systems. The purpose of building, the efficiency of the system, the location and the client's need. Depending on the load-bearing structure, precast systems can be divided into the following categories: large panel systems, frame systems, slab column systems with walls, and mixed systems. Large panel system refers to multi-story structures composed of large wall and floor concrete panels connected in the vertical and horizontal directions so that the wall panels enclose appropriate spaces for the rooms within a building. These panels form a box-like structure. Both vertical and horizontal panels resist gravity load. Wall panels are usually 1 story high. Horizontal floor and roof panels span either as one-way or two-way slabs. When properly joined together, these horizontal elements act as diaphragms that transfer the lateral loads to the walls. Frame systems. Precast frames can be constructed using either linear elements or spatial beam column sub-assemblages. The use of linear elements generally means placing the connecting faces at the beam column junctions. The beams can be seated or corbels at the columns for ease of construction and to aid the shear transfer from the beam to the column. The beam column joints accomplished in this way are hinged. However, rigid beam column connections are used in some cases when the continuity of longitudinal reinforcement through the beam column joint needs to be ensured. Slab column systems. These systems rely on shear walls to sustain lateral load effects, whereas the slab column structure resists mainly gravity loads. There are two main systems in this category: lift slab system with walls, pre-stressed